After designing several PCB versions and airflow setups, it's finally time to assemble the complete Tophat system. In this build, I'll integrate the filtration, lighting, and exhaust, everything designed to work together for better air quality and visibility. The system includes a custom filtration module with PWM control fans, compact lighting strips powered from the mainboard, and an exhaust outlet. I'll start with the frame and panels, then move on to the wiring and configuration. Let's start with the aluminum profiles. The first step is drilling holes for the blind joints on the vertical profiles. I use printed fixtures to make sure each hole is perfectly aligned. Once those are done, I tape threads on the ends of the horizontal profiles to prepare everything for assembly. The process is just like the Voron frame. Blind joint screws slice into the profile slots and pull the corners tight. After the frame was complete, I added D-shaped seal strips along the inner edges, one on top and 4 on the sides. The bottom seal attaches to the printer frame, keeping the top head perfectly flat and airtight. Next are the panels. The dead light pass through while keeping the LEDs outside the enclosure for longer life. I use transparent polycarbonate panels. They are more heat resistant and clearer than acrylic. The top panel needs to handle a bit more load, so it's 4 mm thick, while the sides and the shield panels are 3 mm. Before drilling any holes, I double check that everything was square and true, then trim the panels to size. I don't have a table saw, so I use a handheld tool with a fine 32 TPI blade for a cleaner cut. To keep the edges straight, I clamp an extrusion as a guide. Once the panels were the right side, I mark the hole positions on the top panel. For the tool changer part cooling fan, the filtration intake, and the exhaust fan. I used my circle jig to cut the holes. If you haven't seen it yet, check my previous video. I go over the jig's design in detail. After cutting, I place each component on the panel to mark and drill the mounting holes. The power cooling fan housing has 8 holes, but I only drilled 4 so it can be rotated later to fit the holes better. The exhaust fans and filtration intake also have their mounting holes. I first tried using foam double-side tape for the filtration intake, but the hole stiffness made it unreliable, so I later added screws for a stronger hold. The side panels can be fixed onto the frame with corner bracket first. But for the top panel, I built a sub-assembly with the LED setup. This time, the LEDs are mounted outside the enclosure on aluminum bars for passive heat dissipation. I also upgraded the strips from 12V to 24V, which reduce current draw and allows thinner wires. There are 4 bars surrounding the top panel, each holding a COB LED strip. I cut them to length, soldered them together, and attached them to the bars. Then I assembled everything with custom corner fixings that angle the light slightly inward for better illumination. The fixings also have wiring holes, and I connected both ends of the LED strips to prevent brightness drop over time. A single end feed would work for now, but wiring both sides makes it future-proof and prevents uneven brightness. At first, the LED frame feels unstable since it lacks constraints, but once it mounted onto the top hat frame, it locks into place nicely. With the LED assembly done, I moved on to installing the components on the top panel. The exhaust vent goes first. I removed the corner pads so it could fit snugly into its housing. Then came the pre-assembled part cooling fan and the filtration intake. From past experiments, a direct exhaust caused nearby prints to work from airflow. To stop that, I added a shield that blocks the intakes and separates the buffer zone from the print zone. It's supported by 4 hex pillars near the top panel corners. These placements minimize light blocking while keeping airflow controlled. At this point, the top hat assembly is complete and ready for installation. Before mounting it, I removed the printer deck to cut the outlet hole for the filtration system, again using the circle jig. I recommend using screws for the connector mount because double-side tape isn't strong enough to handle hose tension. After cutting and mounting, I reinstalled the deck. The space underneath the printers was tight for a 90-degree bend, so I added a right angle connector for a cleaner hose route. To install the top pad, the original top panel needs to be removed. Adapt the oil seal strips in place to keep it airtight. I added spacers at each corner to support the new top. Then connected the outlet holes to the filtration system, along with the exhaust valve and intake holes. The exhaust fan's cable doesn't connect directly to the printer's mainboard. It plugs into the filtration system's PWM converter. My printer board only outputs 100 Hz PWM signals, which most PC fans can recognize. So I built 4 headers in the filtration system to convert the low-frequency PWM signals into high-frequency signals for 5V and 12V fans. The filtration fan itself uses voltage control, so it connects directly to the mainboard. The same PWM conversion technique is used across other components in the Tophat system. If you are curious how the circuit works, you can check my earlier video for details. Once everything was wired up, I updated the printer.cfg file. The new part cooling fan uses a 5V control signals from the mainboard, but draws power directly from 24V through its driver. Since the tool changer printhead isn't finished yet, I'll skip testing that part for now. The LEDs runs directly from the 24V on the mainboard, and the filtration and exhaust fan both use inverted PWM signals because of the circuit design. The valve uses simple high and low digital signals to open and close, and I added some G-code markers to automate them so I don't have to toggle them manually. Finally, it's time to test. The lights, filtration fan, exhaust, and valve motions all respond smoothly. Piping valve open and valve close now automatically handles the valve operation. And that completes the Tophat system, featuring the new part cooling fan, exhaust, and filtration setup. It's taken a lot of iterations to get here, but everything finally fits together the way I wanted. With the filtration system connected, I can move forward with future printhead development to see how well it performs. The new external lighting should also last much longer than my previous build. What do you think about this setup? Feel free to leave your thoughts or ideas in the comments. Thanks for watching, and as always, keep moving forward.